Good morning, students. Today we'll do about the classification of crystalline solid. So in last class I have mentioned there are four types of crystalline solid, and based on the type of particles and the nature of the force of attraction between the particles. So I'll give you that classification. So I'll make one table type, then nature of particle, then nature of force between the particles, then example. So as you have got, crystalline solids are classified into four types. Number one, ionic solid. So the solid is said to be ionic solid if the constituent particles present inside the solid are ions. I mean the particles will be positive and negative ions. I mean the cations and anions. And between positive and negative ions, what type of force exists? The force is called electrostatic force of attraction. Electrostatic force of attraction. Example, you can write sodium chloride, potassium chloride. These are the example of ionic solid. In sodium chloride, the particles are Na plus and Cl minus ion. In potassium chloride, particles are K plus ion and Cl minus ion. So this is one type of your crystalline solid, ionic solid. The solid is said to be ionic when the particles are cations and anions, and in between cations and anions the force of attraction takes place, that is called electrostatic force of attraction. Example, sodium chloride, potassium chloride, like that. Number two, covalent solid. This is another type of crystalline solid. A solid is said to be covalent solid if the constituent particles are atoms. I mean inside the solid, if the particles are atoms, then that type of solids are said to be covalent solid. And in between the atoms, what type of force exists? The force is called covalent bonding force. Covalent bonding force. So based on this type of force and based on the constituent particles, you can classify the solid as ionic covalent. Covalent solid example, you can write graphite, diamond. These are the example of covalent solid. And if you want to know about the physical nature of ionic solid, covalent solid, in case of ionic solid, normally physical ionic solids are hard one and they are bad conductor of heat and electricity in solid state, but in aqueous solution they become good conductor of electricity. I mean when you dissolve in water, if the sodium chloride, potassium chloride, if they are dissolved in water, then they produce ions, and that is why in aqueous solution they become good conductor of heat and electricity. But when they are in solid state, they cannot produce ions, and that is why in solid state they become bad conductor of electricity. And if you want to know the physical nature of covalent solids are also hard and they are insulator. I mean they cannot conduct electricity. Number three, which is called molecular solid. And in case of molecular solid, the particles are said to be molecules. But molecular solid, again you can classify it into three types. I mean there are three types of molecular solid. So first time I will give you the type as ABC. Number A, polar molecular solid. Polar molecular solid. Number B, non-polar molecular solid. Non-polar molecular solid. And number C, hydrogen bonded molecular solid. There are three types of molecular solid I have given as ABC. So in all these cases the particles will be molecules, but nature of molecules will be different. In case of polar molecular solid, the particles are polar molecules. In case of non-polar molecular solid, particles are said to be non-polar molecules. And in case of hydrogen bonded, the particles said to be the hydrogen bonded molecules. So all are molecules, but the nature of molecules are different. And in case of polar molecules, what type of force exists? The force is called dipole force. In class 11 you have got between polar molecule, the force of attraction exists is called dipole force. So if your molecular solid is polar molecular solid, then the force of attraction between them is called dipole force. In case of non-polar molecular solid, the particles will be non-polar molecules and the force of attraction is called London force or dispersion force. London force or dispersion force. And hydrogen bonded, in case of hydrogen bonded molecular solid, the particles will be hydrogen bonded molecules and the force is called hydrogen bonding molecules. Hydrogen bonding molecules. And if you want to know the examples of polar molecular solid, non-polar molecular solid, then one example you can write. Polar molecular solid example you can write solid HCl. It is one example of polar molecular solid. Non-polar molecular solid you can write solid iodine. Iodine is non-polar. And solid carbon dioxide also you can write, because carbon dioxide is also non-polar molecule. And hydrogen bonded molecular solid example you can write ice, because in ice hydrogen bonding takes place between water molecule. So these are the example of molecular solid. Again, molecular solid there are three types. One is called polar molecular solid, one is called non-polar molecular solid, and one is called hydrogen bonded molecular solid. In all these molecular solid, the molecule characters are different. Polar molecules, non-polar molecules, hydrogen bonded molecules, and based on that their forces of attraction is also different, and the examples are these are. And the last one, I mean number 4, which is called metallic solid. In metallic solid, the particles will be positive metal ions with the sea of mobile electrons. With the sea of mobile electrons. I mean, as you know, metal contains some loosely bonded electron. So that electron will be released by the metal atom and the metal become positively charged, and the electron will be mobile inside the lattice. So some positive ions you will get, that suppose this is positive metal and this is your removing electron, this is metal and this is your electron. This type of arrangement you will get inside the metallic solid. I mean, some positive metal ions you will get and some mobile electrons in between the positive ions you will get. So in case of metallic solid, the particles are positive metal ions with a sea of mobile electrons. And what type of force exists? The force of attraction in metallic solid is called metallic bonding force. Metallic bonding force. An example, if you want to write, you can write all metals except mercury. Mercury exists as your liquid, but other metals exist as solid. So all metals are the example of metallic solid. So, and if you know about the physical nature, metallic solid is one of the solid which are good conductor of heat and electricity. Molecular solid, generally they are soft, their melting points are low, and they become insulator. So in solid state, ionic solid, covalent solid, molecular solid, all are insulator. Only metallic solid is good conductor of heat and electricity in solid state. Yes, ionic solid become conductor when it is in aqueous solution. In solid state, it becomes insulator. So that is why the question may be asked like this: what type of solids are good conductor of heat and electricity? Then you have to write metallic solid. Don't write ionic solid, because in solid state ionic solids are insulator. So this is about the classification of crystalline solid. Crystalline solid can be classified into 4 types: ionic, covalent, molecular, and metallic solid. Molecular solid again classified into 3 types: maybe polar molecular solid if the particles are polar molecules, maybe non-polar molecular solid if the particles are non-polar molecules, and maybe hydrogen bonded molecular solid if the particles are hydrogen bonding with each other. And based on that, your force of attractions are different. and their physical nature also different. In exam you may the question may ask like this, what type of particles and what type of force of attraction exists in between the particles in case of ionic solid. Then you have to write the answer. In ionic solid the particles are positive ions and negative ions, and the force of attraction in between them are electrostatic force of attraction. That type of question may ask, and maybe some example asks, give one example of covalent solid, give one example of polar molecular solid, like that. Thank you.